this lesson of the techniques and applications of definite integration, we will be taking a look at two examples. So here is the first, where you have a double integration y is greater or smaller to 0, smaller or equals to 1, while z is greater or equals to 0 and smaller or equals to 3. Your integrand is square root 1 minus y squared dy dz. So you might be thinking this question seems a bit weird, isn't it? Since normally you will see dx dy, but of course whatever's behind it can definitely change to whatever you like, alright? So dy dz, and you're given this boundary. What will this boundary look like? So this boundary, you have your y-axis and your z-axis. So y and z. Y is from 0 to 1. Z is from 0 to 3. And there are no other limitations, which means it is basically a rectangle. Alright? So this is what your region of integration would look like. Right, so that is for this example. Now we can change it into an iterative integration form. So you have two different integrations, and you realize your integrand is entirely about y, which means you could just integrate z separately, since they are pretty much independent of each other too. Alright, so let's say this is dz, or I'll just close up the gap. Alright, so integrate dz 0 to 3, and then integrate from 0 to 1 square root 1 minus y square dy. So of course dz, you can directly find it. But how do you integrate for the term with y? Well, there are a few different methods. Firstly, you can choose to use a trigonometric substitution, or you could choose to use integration by parts. How about let's take a look at your trigonometric substitution method. Right, so since this is 1 minus something square, that means this something would be either sine or cosine. So how about let y be sine theta. So dy is cosine theta d theta. And then of course your range for theta. Now y is 0 to 1. So sine something that gets 0 would be 0. So theta is from 0 to, now sine something and get 1, which is half pi. So theta is from 0 to half pi. Right, so the integration in front, you get 3. And integrate from 0 to half pi. 1 minus sine square would give you cosine square, which gives cosine theta. But your dy, you have another cosine, which gives cosine square d theta. And since now you have a cosine square, you could just use your double angle formula in order to finish your integration. So half from a double angle formula, and cosine square, you'll just have 1 plus cosine 2 theta d theta. So for your previous term, you will have 3 over 2 theta, integrate from 0 to half pi. And then for your term behind, you will have plus 3 over 4 sine 2 theta, in substitute 0 to half pi. And now we substitute in the values. So for your first term, you have 3 pi over 4. And then of course sub in 0 is 0. Or for your second term, sine pi is 0, sine 0 is 0. So your final answer would be 3 pi over 4. Alright? So that will be your answer for this first question here. Right, so what kind of method did we exactly use? So we first knew that this boundary is of a rectangle, and this rectangle, then we could determine what exactly are their boundaries, which are actually pretty much given, so that doesn't really matter. And then you change them to enter into integration, magnitude normal change substitution, and integrate to find your final answer of 3 pi over 4. Right, so next we'll be taking a look at the second question. Right, so here is our second example. In this second example again, we have a double integration, but our boundary this time is x squared plus y squared is smaller or equals to 1, and our integrand is square root 1 minus x squared minus y squared, then the sigma. Alright, so how do we solve this question? Firstly, what exactly is the region we are taking a look at? So first things first, x-axis, y-axis, alright? So x-axis and y-axis. And our function is x squared plus y squared is smaller or equals to 1. So x squared plus y squared is smaller or equals to 1, that means it is basically a circle centered at the origin with the radius of 1, alright? So here you have 1, 1, negative 1, negative 1, alright? So this is basically the region you have. Alright, so what would be so special? Now, since you have to integrate this portion here, is it simpler to integrate it while in Cartesian form, or is it simpler to integrate it in a polar form? So definitely you would want to change it into a polar form, right? So in polar coordinates, what you will have essentially is square root 1 minus x squared minus y squared. If you realize, negative x squared minus y squared is basically minus r squared if you change it into polar coordinates, since x is r cosine theta and y is r sine theta, right? And then you have the sigma, which is r d theta. So range for r, it will be from 0 to 1, which is your radius. Range for theta, that will be 0 to 2 pi, which is basically your entire circle. Right, so this is what we're going to integrate. Now in this part of integration, you will realize there are many parts without r, and the only parts, there are many parts with r, and the only parts with theta is essentially integrate from 0 to 2 pi d theta, which you can integrate directly to get 2 pi, alright? But you would have to realize that inside here, integrate 0 to 1 square root 1 minus r square r dr, you will need to put your r inside the dr with a negative, which gives a negative pi, integrate from 0 to 1, and you have square root 1 minus r square d negative r square. Alright, so at this part, then you can integrate it, since you probably know how to integrate those with square roots. So negative pi multiplied by 2 over 3 square root 1 minus r square cube, substitute in 0 and 1. Alright, so when you put in 1, this is a 0, and when you put in 0, this is a 1, but you have another negative, so you have 2 pi over 3. Alright, so this is your final answer you will get for this example. So this example should be relatively simple, since your procedures are basically you start off knowing that this is a circle. So since you know it is a circle, you would want to calculate it in polar coordinates rather than Cartesian coordinates. So you change that into polar coordinates, and just do some simple integration. Of course, you have to know your integration formulas, and after you do the integration, you get the answer of 2 pi over 3. So the two examples in this lesson, I hope you'll be clear with them so far. I'll be ending this here, and thank you for your watching.